This video introduces viciLogic, the online learning, assessment and hardware prototyping platform for digital integrated circuits. Two elements of viciLogic are described: viciLearn, which is the online learning and assessment platform, and viciLab, which is the hardware prototyping platform. Digital logic integrated circuits, or ICs, are the amazing high-performance computing engines within modern devices such as computers, notebooks, phones, medical equipment, cars, cameras and games. Modern digital ICs, or silicon chips as they are often called, provide millions of hardware logic elements which can operate in parallel to process digital data at up to gigahertz speeds. This fantastic IC technology is normally hidden deep within the devices that we use every day. viciLogic enables the next generation of IC designers. viciLogic provides interactive control, probing, and visualization of real digital logic hardware devices in the cloud in real time to better learn, understand, and demonstrate digital logic hardware behavior. viciLogic makes industry-level integrated circuit design accessible to everyone. viciLogic bridges the growing gap in knowledge of what's inside these modern digital logic electronic devices, enabling the next generation of designers. So, viciLogic uses digital integrated circuit hardware in the cloud. It uses reconfigurable logic integrated circuit devices, also referred to as FPGAs, field programmable gate arrays. The techniques learnt using viciLogic can be used to design either reconfigurable logic hardware, FPGAs, or full custom integrated circuits, termed ASICs. Integrated circuit devices contain vast amounts of hardware resources, from thousands to millions of digital logic building blocks and memory elements. Digital systems design engineers and computer architects connect these logic resources together to create sophisticated, high-performance hardware. viciLogic includes viciLearn and viciLab. viciLearn is an online learning and assessment platform. Simply register on vicilogic.com and press Get Started to follow a viciLearn online directed self-paced modular learning and assessment program. Here are some examples of viciLogic training modules. This step illustrates an M21 timing diagram. Timing diagrams display the progress of signals over a series of time steps. In this example, signal cell is logic 1, muxin 0 is logic 0, and viciLogic toggles signal muxin 1 several times. This behavior can be observed on the M21 component symbol, signal icons, and the timing diagram. In this sandbox, modify the M21 input signals to observe the behavior of each of the M21 component description views: the component symbol, the function table, the truth table, the lookup table, and the timing diagram. When you've selected the required input signal logic levels, select Step Timing Diagram to enter a new input signal combination. This step presents a 2-to-1 multiplexer VHDL hardware description language model. VHDL is a program-based description of digital logic functions. In this sandbox, modify the M21 input signals and observe the behavior of the VHDL model. The widget highlights the active VHDL assignment. This step illustrates the animated truth table descriptions for the NS-decode-I component and their implementation using FPGA lookup tables. Two truth tables exist, one for NS1 and one for NS0. CS is the truth table input. The step also includes the two D flip-flops 2-bit count register and their connection to the LUTs to implement the CB2C counter component. Toggle the clock to observe the behavior of the internal components, the FSM drawings, timing diagram, and DFD. So, these examples have illustrated that viciLogic brings any diagram representing a digital system to life by automatically connecting it to signals within real, operating, remote FPGA hardware. Learn by doing, by interacting with animated views of the internal behavior of real digital logic hardware operating in the cloud. While viciLogic hardware is remote, it feels real and local to the user. viciLearn offers structured, directed, self-paced, modular training programs with interactive demonstrations, knowledge checks, and optional formal assessment. Follow a series of modules on digital systems design from component level to system level. Develop practical digital logic design, hardware description language models, simulation, and hardware implementation and test skills using remote FPGA hardware. Tutors can integrate their own course material and hardware design examples within the viciLearn modules. viciLab enables prototyping and animation of your own digital logic designs. You can design, build, control, animate, and demonstrate your own hardware design prototypes using viciLogic remote FPGA hardware or using your own local FPGA hardware. Quickly build FPGA hardware and graphical user interface consoles which interact with your hardware prototype. Use automated industry-level design and FPGA implementation tools. viciLab enables you to integrate sensors and actuators connected to your FPGA prototype. The operation of viciLab is described in a separate video.